Hello, Mr. Claudia here, and today we are going to be looking at solving logarithmic equations. In our last lesson we solved exponential equations, and so now we're going to move on to logarithmic equations. Remember, an equation means there's an equal sign, and there's an unknown variable like x that you're trying to solve for. One thing we should keep in mind, and one little headache we're going to have today, is if you remember we have log b base a, we have to always remember and check that b is greater than 0, so b cannot be negative, and a is greater than 0. So keep those two things in mind. Much like with exponential equations, there are a few different methods here to solve logarithmic equations. The first one, again, is very similar to exponential. This is where you can equate the argument if the bases are the same. So look at this equation here. We have the same bases. So essentially, we can equate the arguments. So 3x minus 5 is equal to 16. I have not made up any math. What I do to one side, I do to the other. Technically, what I'm doing is I'm raising both of these to 7 to the power of, 7 to the power of. But an easy way to look at it is because the bases are the same, I can just equate the arguments. Okay, and now this is a simple linear equation to solve. I can bring the 5 to the other side, and x is equal to 7. Perfect. Okay, let's do this next question here. Oh, can I equate the arguments? Well, there might be a tendency for you to write x minus 3 is equal to, but you can't do that. To equate the arguments, you have to have one log on one side, one log on the other side, and they have to have the same base. Here I have two logs on this side, log base e, also called ln, and I have one on this side. So I have to somehow combine these two into one logarithmic expression. Fortunately, we spent a lesson on that, log laws. So I'm going to apply my log laws to combine these. So first, the 3 becomes an exponent. That's what my third log law. Actually, I can do that here too. I get ln 3 squared. And now I can combine this, these two using the subtraction log law. So it's going to be x cubed over 3. Ln 3 squared is actually ln 9. So the first step, I used my log law. I used another log law. And now, because these are the same base, remember ln just means log base e, I can equate the arguments. So I get x cubed over 3 is equal to 9. Now I just need to solve this, so I cross multiply, I get 27. The cube root of 27 is 3. Great. So we like this kind of solution where we can equate the arguments. It's very convenient. But as you would guess, we're not always going to have this great situation where the bases are the same. So let's go to our second method, our final method, method 2, convert to an exponent. If you reach a situation where you have one logarithm is equal to some sort of number, we can rewrite this as an exponential equation, which will be easier for us to solve. So for this case, for example, here's one log expression equal to a number. Let me use the definition of a logarithm to rewrite this. So it's going to be base to the power of 0 is equal to x squared over 3x plus 4. All I've done is rewrite the logarithm as an exponential. Now, a to the power of 0, it doesn't matter what a is, this is always going to be 1. So 1 is equal to x squared over 3x plus 4. It's a bit of a tricky one, right? That's a special case. Okay, now fortunately it looks like it's just going to be a quadratic expression. I'm going to cross multiply, so 1 times 3x plus 4, and remember this is over 1, so when I cross multiply I get x squared. anytime you have a power of 2, this is going to be a quadratic equation, so I'm going to solve it using my quadratic strategies, which is by factoring. So I'm going to bring everything to the same side. Now I'm going to see if I can factor this by inspection, like what I like to do. So two numbers that multiply the 4 would be 2 and 2, but they're not going to add to 3, so it's got to be 4 and 1. 4 is more negative. That should work. So therefore, x is equal to 4 and x is equal to -1. Now, here's the problem. I do need to check that both solutions are going to give me a positive argument. So, let me just make a note. Check that the argument is positive for both solutions. So if x is equal to -1, let's start with that one. Then I have, okay, so if x is equal to -1, is this going to be positive? Let's check. -1 squared over 3 -1 plus 4. That gives me, okay, 1 over -3 over plus 4. So whatever this is, it's going to be positive. So that's good. I don't even need to really figure out the number. I just need to make sure it's positive. And if x is equal to 4, I have 4 squared, 3 times 4 plus 4. And I can tell you right away that's going to be positive. So great, both solutions are valid. So you have to do that check for the argument and sometimes for the base. Okay, let's do this next question. Now, here I have a bit of a problem. Okay, so I mean, there are a few different ways of solving this. If only I could get this to be log and log, then I could use my method above where I equate the arguments. But I can't in this case, or I could, I'd have to do some manipulation of the two. But what I could do is try to get into this form where I have a log on one side and a number on the other. And I can do that by combining these two logs using log laws. So watch what I'm going to do. I have 2 is equal to 4 log x minus log x. So I brought this log to the other side. Now, it's just a simple matter of using log laws to combine these two expressions. Let me bring the 4 up here. And now let me use another log law to combine these two. So I would get log x to the power 4 over x. And when I divide that, I get 2 is equal to log x cubed. Now I have this situation where I have a log on one side and a number on the other. So now I can convert to an exponential equation. There's no base here, but we know there's a base of 10, if it's none shown. So this is going to be 10 squared is equal to that argument x cubed. So that means 100 is equal to x cubed. Sorry, forgive my mess here. Let me just draw a line here so that we don't. We'll draw a little wall to keep these two questions apart. Okay. Now, what's the cube root of 100? I don't know, I don't have my calculator handy, but either way it's got to be positive. Now, if it is positive, this is going to be okay and this is going to be okay. So as long as it's positive, it's fine. So my check is good. This answer would be valid on a non-calculator exam. If you did have a calculator exam, you'd have to actually figure it out. So we'd have cube root. There, something like that, 1.01. Or no, I did it wrong. So it'd be 300. There, 4.64. That's the actual answer if I had a calculator exam. Okay, next question. Now, again, I need to solve this logarithmic expression. Either I could try to get a log on one side, log on the other side, or I need to get it so that I have one log and a number on the other side. Looks like I'm pretty close. I just need to combine these two logs, and they have the same base, so I can use my log. Log base 2. Now if I'm going to combine this addition of logs, I'm going to combine it with multiplication. I'm going to use some brackets because it's getting a little confusing here. And now I can multiply what's in my bracket, so I end up with x squared plus 2x equals 3. Now I have this great situation. Log on one side, numbers on the other. It's very easy to solve, or it's very easy to rewrite. 2 to the power of 3 is equal to x squared plus 2x. Now 2 times 2, that's 8. So, and this is going to be a quadratic, so let me rewrite this. And let me solve this quadratic. Hopefully I can do it by factoring by inspection. 8 is 2 times 4. That looks good. So I'm going to have a negative 4. No, I'll have a positive 4 and a negative 2. So therefore, x is equal to negative 4 and x is equal to 2. Oops. Let's see, make sure you can see all that. Okay, we should do a quick check. If x is equal to negative 4, then, okay, so if x is equal to negative 4, oh, well, we're going to have a big problem because you can't have a negative, right? I'm not allowed to have a log of a negative number, so this does not exist. If you don't believe me, right, if I go to my calculator, log negative 4, doesn't work. So there's no such thing as a negative argument, so this is the problem. So that would not be a solution. What about if x equals 2? Well, then we have log base 2, 2 plus 2. Yeah, so this one does work because it will be positive. So something to make sure we do, we have to check. Let's turn the page. We have some ominous looking questions to do here. These are a few examples. Again, you might want to try them on your own and then come back and see what the solution looks like. So good luck with those. Okay, and welcome back. So here we go. Let's try to solve these questions. Now, this is a logarithm, so I got to remember, how do I solve log equations? Well, I can either equate the arguments, but can't do that here. My second option is to rewrite as a exponential equation. Okay, so I'm going to start with the base, x plus 2, and I have to raise that to the thing on the other side, the equals, which is 2, and that's going to be equal to the argument, which is this long quadratic expression. Oof. Now, that looks scary, but the good news is the log is gone. And the good news is I know how to solve this. I solve this by foiling. This is going to be x times x, which is x squared plus 4x plus 2 times 2 is 4. If you need to show more work for that, that's okay. Now, this is a quadratic expression or equation. How do we solve quadratic equations? We collect all the like terms, make a quadratic, and then factor it. So let me bring all of these to the other side. So that's going to give me 2x squared plus 16x minus 4 is going to be minus 18. Okay, I'm going to try to factor this by inspection, but first let me recognize that I can factor out a 2. It's very hard to factor when there's a coefficient, but luckily I can factor out this 2, so maybe I can still factor by inspection. You might be like wondering about my factoring, like, oh, you're really fortunate that it works out so well. But in IB, the questions, the exam questions tend to, if you're going to have a small quadratic to do in a question like this, it often will work out by factoring. So let's see, can I do this one by inspection? X. Okay, two numbers that multiply 9 are 9 and 1, and yes, it would be positive 9, that would give me a high number there, and minus 1. So my solution is x is equal to negative 9 and x is equal to 1. However, I do need to check, so let me go check. If x is equal to negative 9. Okay, well there's a few things I have to check here. I have to check the argument and I have to check the base, which is annoying. But we will do it. So let's check the argument because they both have to be positive. So the argument would be 3 times negative 9 squared plus 20 times negative 9 minus 14. Okay, so 9 times 9 is 81, times 3 is 243, minus 20 times 9, which is minus 180, and minus 14. I'm not going to do the math because I know that those are going to be, the positives are going to win out. So that's okay. Let me check the base. So that's this part here. That's going to be x plus 2. So it's going to be negative 9, which is what x is, plus 2. That gives me negative number, less than 0, so it does not exist. So there's a problem there. This is invalid. What about if x is equal to negative, or no, x is equal to 1? Well, we have to check the argument. So I have 3 times 1 squared plus 20 times 1 minus 14. 20 minus 14, that's definitely going to be greater than 0. And we have to check the base. 1 plus 2 is greater than 0. So this one is good. Whew. Okay, and next question. Now I put this one on because this is our last kind of big technical lesson on logs. And this really strikes at how well we understand the log notation. So when I have a log x squared, the squared applies to the x. Now, fortunately with log laws, I can bring the 2 down. This expression, log x base 2 all squared, means that it's log x times log x. In fact, let me write that out. So, this 2 I can bring down. 2 log base 2x. This is log base 2x times log base 2x. This is a tricky question, but that helps me decode these two different squares and kind of the difference in the notation. Now, I don't know if you guys see it, but let me bring this to the other side. So I'm going to have log x base 2 times log x base 2 minus 2 log x base 2. And I can actually factor out one of those logs. And I'm left with log x base 2 minus 2. Now hopefully that what I've done is logical enough. I can't do anything here with equating bases because they're technically different expressions. So what I'm doing is I'm collecting all my terms. This is technically a quadratic. If you want to look at it this way, it's 2a equals a squared. That's really what it is. And if you could replace the logs with an a, and then you could solve for a, and then you could figure out what the log x base 2 is. But in this case, what I'm doing then is bringing everything over, and I'm factoring out the log x. I'm factoring out one of the variables, and this is what I'm left with, log x from here. And then when I factor out log x, I'm left with just 2. So now I factor the quadratic. I factored this equation. Now there's really only 2 ways that this can equal 0. That would be if this first thing is equal to 0. So if log base 2x is equal to 0. Or if the second thing. So how do I solve this though? How do I figure out what x is with a log expression like this? Well, we just learned in this lesson. I can rewrite it as an exponent. 2 to the power of 0 equals x. To the power of anything to the power of 0 is always 1. So the answer here is 1. Over here, I can solve this if I bring 2 to the other side. Then I rewrite as an exponent. 2 to the power of 2 is equal to x. Therefore, x is equal to 4. Let's do a quick check. Will 4 and 1 suffice? They're both positive. Positive, positive. So check. It works out. Okay, and now we're into the advanced questions, which again sounds scarier than it is. in this question, first of all, what is it? It's an equation. It's a log equation. So there's two possibilities. I need to have two logs on opposite sides of the equal sign. I equate the arguments. That's going to be really hard here because there's a number, and look, these don't even have the same base. In fact, before I do anything, I need to get these to be the same base. If I'm going to combine these, they need to be the same base if I'm going to do anything. So is there a way I can change the base of one of these? Oh, yes, there is. I learned a change of base formula. So I'm going to change this expression to have base 4. Hopefully you remember how to do this. You can go back and check your change of base notes. So maybe I can find my change of base notes and I can show you. Here we go. So if you have a log, you rewrite it as log of the argument over log of the base, and then you choose your new base. As long as you use the same one, it's okay. So let's rewrite this as log of the argument over log of the base. Now what's my new base going to be? Well, I want it to match this, so I'm going to choose 4. I have not made up any math, I'm just using the change of base formula. And again, it's kind of the question screaming at you to change the base because these are different. And the change of base formula is on your formula sheet. Okay, now what? Well, I want to combine these. That's what I did in the previous questions. What is this? Log 2 base 4. Remember, log of a number is just some sort of number. You could go to the top of the gym and say, what's log 2 base 4? And someone should yell back to you what it is. Let's just go over here and think about it for a sec. Log 2 base 4 is equal to question mark. Well, I can rewrite this as 4 to the power of question mark is equal to 2. What exponent is going to make this true? Well, it's essentially a square root, right? If you take the square root of 4, you get 2, and that means the exponent has to be half. So that's just a little close-up of what we did here. So I'm going to replace that value for that log expression with half. Now, I'd like to combine these. Let me try to get rid of this half. I mean, something over half, I can take the reciprocal. So I'm going to end up with log base 4 x cubed plus 2 log 4 root x equals 8. Okay, so we're getting pretty close to combining these two log expressions, but we do have this pesky 2 here. But we can get rid of that 2 using a log law. So let me rewrite this again. Log x cubed base 4 plus log base 4 root x, and the 2 comes up here, and technically that 2 is applied to the argument. Well, this is very fortunate because root x squared is just x. So I end up with log base 4 x cubed plus log base 4 x equals 8. Now I can combine these two log expressions by multiplying the arguments. This is my first log law. So I have x cubed times x. Again, I find this to be a little ambiguous. I always like including extra brackets for that one. And I end up with log base 4 x to the 4 is equal to 8. Oh, after all this work, now I am ready to solve this log equation. I've simplified it to have a log on one side, a number on the other. Now I rewrite as an equation 4 to the power of 8 is equal to x to the power of 4. How do I get rid of the power of 4? Well, if you remember from grade 10, you can take raise this to the 4th. You can raise this to the 4th. What you do to one side, you do to the other. So 4 to the 4th, this is going to become x, and this is going to become 4 to the 8 over 4. Or, in other words, 4 to the 2. That means x is equal to 16. Oh, there it is. Oh, what a marathon. If we look up the x, okay, 16 is going to be positive, 16 will be positive. So if I do a quick check, it's okay. Okay, do we have energy to do one more? Of course we do. Remember this last question up here, how I said it was like a quadratic. And if you could just imagine it as a's, you would be able to solve it by factoring. Well, this question, if I look at it, this is definitely a quadratic. Here I have something squared, I have that something again, and then I have a constant term. Let's try solving this question, not by factoring logs. Let's try actually using substitution. So this is a strategy we can use in a question like this. We let a equal log 2x. So when or log x base 2. So I'm saying, hey, I'm going to replace all of these things with a. So I have a squared, this becomes minus a, this stays as 2. Now I'm going to solve this question, which is just a quadratic, a nice one actually. Let me see if I can factor it by inspection. So I have minus 2 here, and I have plus 1 here. So I end up with a is equal to 2, and a is equal to negative 1. Now here's the only thing about solving with substitution. I'm going to call this substitution method. Here's the only issue. I haven't solved my question. My original question was, what is x, right? This equation is saying, what is x? And I know what a is. Well, the question wasn't asking for a. What is a? Oh yeah, I just called a this variable. So what I can do now is sub that back in. So that a is log x base 2 is equal to 2. And over here, log x base 2 is equal to negative 1. Now I can solve these log expressions using the strategy we've been doing all day. 2 squared is equal to x, so I have x is equal to 4. 2 to the negative 1 is equal to x, so x is equal to half. Those are both positive, positive, positive. Everything works out. So I'm just going to do a quick check. Okay. All right, so that is our last big technical lesson on logarithms. You should now be logarithm experts. Remember, my big thing with this chapter is not making up math. And I hope the things we've done in this chapter you'll remember for the rest of your IB math journey, because they do tend to come back sometimes, and that's when you start to forget how to deal with them. Here's your homework. So page 30, number 1, and page 131, number 1 to 5. Good luck, and we'll see you next time.